Today we are going to discuss about one most important thing. This concept is given in wave motion chapter. Okay, specifically in single slit diffraction, this concept is given. And one more thing is the question is also given in page number 103. The question number is 18th question. Discuss the special cases on first minimum in Fraunhofer diffraction. That is the question. This one may be asked in 3 mark. Therefore, I am going to explain thoroughly about the concept. Okay. So let's see the diagram. Already to save the time I have drawn the diagram. Look at here. This is called single slit. If you make a small hole in a paper or in a sheet, then you will get a single slit. The width of the slit must be taken as, that is the width of the hole must be taken as small a, and then one monochromatic source is kept on the other side. So the light is which is made to emit the clear from the source, and it is made to incident on the single slit. After getting diffraction, bending of light happens, no, the clear, because of bending of light, diffraction will happen. Because of diffraction, you will get the diffraction fringes. So we are not going to bother about the complete pattern of the diffraction pattern. We are going to concentrate only on the first minimum. So what is first minimum here? The center part of the diffraction fringe, there you can observe a central maxima. On either side of the central maxima, you could observe a dark fringe, dark region. These two dark fringes, they are called as first minimum. Are you clear? You should know what is first minimum. This is the most significant one. Are you clear? Now, this central maxima that is lying in between these two first minimum, that is most important thing. Okay. Here, look at the geometrical factors. The width of the slit should be taken as A, and then the wavelength of the light which is emitted from the source, no, that light has got its own wavelength, that should be taken as lambda. So A is the width, lambda is the wavelength, and then you have to draw a straight line from the single slit, and that reaches the central part of the central maxima, and then you have to draw another line that connects the first minimum from the center. Here you will get an angle. That angle is called angular spread. So by using this A, lambda and theta, we can write the equation for first minimum. To observe the first minimum, this is the condition. Here, otherwise we can call it as the path difference. Is it clear? To observe the first minimum. Otherwise we can call it as equation for first minimum. The equation for observing the first minimum, these two are called as first minimum, no? To observe the first minimum, this is the condition. So what is the condition? Already this formula was already derived while teaching the theory of the single slit diffraction. So A sin theta is equal to lambda. So this is the very important equation, is clear, which is also called as equation for first minimum. Here A is nothing but width, lambda is the wavelength, theta is the angular spread. So first you have to write this expression while starting the answer. Therefrom you will get another answer called, what is this? Angular spread. What is angular spread? Here, this is the region in which central maxima is there. If you draw a conical structure, there you will get an angle, no? This angle is called angular spread. Angular spread is nothing but angle. Here to get this angle theta, this equation to be used. So sin theta is equal to, keep sin theta in one side, this A can be brought down. So from this equation, you are able to get the expression for angular spread. Are you clear? So the central maxima that lies in between these two first maximum, there you will get an angle. That angle is called angular spread for first minimum. So keep these two equations ready. In the next successive 4 steps, I am going to explain what will happen. Is it clear? If you compare lambda and A, we are going to discuss 4 different cases in which we are going to vary the value of lambda or A. Are you clear? In one case, we can keep lambda and A both are equal. In another case, any one of the factors may be more, any one of the factors may be less. So by varying the value of lambda and A, we are going to observe what will happen in the first minimum and also in the central maxima region. Okay. Now we are going to discuss the first case. So we'll write the case 1 now. Here I have taken two values. Here the width of the slit is taken as 3000 Armstrong unit and the wavelength of the light is 5000 Armstrong unit. You just compare the value of A and lambda. Compared to the A value, lambda is greater. Nuclear wavelength is greater, width is lesser. So how it should be written? A is lesser than lambda. So this is the first condition. Are you clear? We know the equation of first minimum. What is the equation of first minimum? A sin theta is equal to lambda. Keep sin theta value, sin theta in one side, lambda by A can be written. This A can be brought down. And then just for understanding purpose, I will write this value. Substitute here, instead of lambda, substitute 5000 Armstrong unit. And then here one typical value is taken. The value is how much? 3000 Armstrong unit. After cancelling, how the value will be? This value after calculation, this value will be greater than 1. So clear, you know about the fundamentals. The sin theta value, is it clear? That one will be equal to 1. That is the maximum value of sin theta. Are you clear? So here the sin theta is greater than 1 means it is not possible. Are you clear? Sin 90 is equal to 1. So the sin theta value, it cannot be greater than 1. Therefore, this condition is not possible. This is not possible. Therefore, since sin theta cannot be greater than 1, here no diffraction pattern can be observed. On the screen, you can't see any diffraction pattern. That's why I left blank here. No central maxima, no fringes, nothing would be observed here when this clear condition is followed. When A is lesser than lambda, no diffraction pattern would be seen here. That is the first conclusion. Okay. Now we are going to discuss the second case, very interesting case. So in which the width of the slit A is equal to 5000 Armstrong unit. And then the wavelength of the light which is used here is also equal to 5000 Armstrong unit. Therefore, A is equal to lambda. So in the case 2, I will write, you also follow me. In case 2, A is equal to lambda. Are you clear? Just I will write both the two value here. A is also 5000 Armstrong and the width of the slit is also, wavelength also equal to 5000 Armstrong unit. So what is the condition for observing the first minimum? We know very well that A sin theta is equal to lambda. Are you clear? Write this value here. Sin theta is equal to lambda by A. Substitute both the two value. Sin theta is equal to 5000 Armstrong divided by 5000 Armstrong, which is equal to, just for understanding purpose I have substituted. This one need not be written in the exam. Okay, so this value is equal to 1. If sin theta is equal to 1 means, what would be the value of theta? We know very well that sin 90 is equal to 1. Therefore, the angular spread theta value will be equal to 90. What is the meaning now? So I have drawn one line here. Are you clear? So with respect to the line alone, we can measure the angular spread. Angular spread means, so clear, this, you have to draw one more line towards the screen and look at the value of theta. This is called theta. This one to be extended, this one should be extended. If it is further extended, this is the clear ray which goes in this direction. Are you clear? Because of the bending, the entire screen will be occupied by which one? Central maximum. You can't observe the first minimum. Are you clear? Because of bending, what happens? On either side, here this angle would be equal to, I will draw the diffracted ray. Here, this is the diffracted ray. This angle is called angular spread. Because of the angular spread, the entire region will be fully occupied by central maximum. Not only here, in this region also. You have to extend the line and another diffracted ray to be drawn here. Are you clear? And here also the angle will be equal to 90. So you can't observe the first minimum. the entire screen will be fully occupied by which one? Central maximum. Okay. Now we are going to analyze the third case. This is the most important case because in this condition alone, we can observe the diffraction pattern very clearly with a large number of fringes. What is the condition? Look at here, the wavelength of the light used is 5000 Armstrong unit and the width of the slit is A. Look at the value taken here. The width of the slit is 2 times of the wavelength. Exactly, it should be few times of the wavelength of the light. Here I have taken 2 times of the wavelength of the light. 2 times of the wavelength of the light means you just convert it into millimeter. 2 into 5000 Armstrong unit. 2 into 5, 10, remaining 3 zeros are written. 10,000 into 10 to the power of minus 10 meter. After that, after converting, you will get 10 to the power of minus 6 meter. This one could be written as 0.001 meter, millimeter, 0.001 millimeter. So this one must be the width of the slit. The width of the slit is how much? 0.001 millimeter. This is equivalent to 2 times of the 5000 Armstrong unit. Are you clear? That is 2 times of the wavelength. Here A is 2 times of the wavelength. It shows that which one is greater? A should be greater. A is greater than lambda. That is width of the slit is greater than lambda. Now I am going to write the third condition. Case 3. I am going to write the case 3. Are you clear? As per the diagram, which one is greater? A is greater than lambda. How many times it is greater? As per the calculation, A is 2 times of the wavelength. Just for reference, I have taken, just for understanding purpose. A is 2 times of the wavelength. Now we know the condition for first minimum. What is the condition for first minimum? A sin theta is equal to lambda is the formula. This is the condition for first minimum. Now you write it here, sin theta is equal to lambda by A. Substitute this value, sin theta is equal to lambda divided by, instead of A, substitute 2 lambda. Cancel this. You will get sin theta is equal to half. Sin theta is equal to half means what would be the value of theta? Sin 30 is equal to half. So therefore theta value would be 30 degree. What is theta is equal to 30 degree? What it refers? Theta is equal to 30 degree means here the angular spread would be 30 degree. So in this, within this 30 degree, in this region, which one appears? The first minimum appears. It is within the screen, we are able to observe the central maxima, first minimum, and other fringes can also be observed. To observe the complete pattern of the diffraction pattern, clear what should be the condition? The most important condition is A should be greater than lambda. Very important one. To observe the complete diffraction pattern, how it should be? The A value should be few times of the wavelength. Few times of the wavelength. That is very important. So don't forget the third condition. Okay. Now we are going to discuss the fourth case. Look at the fourth case. Here the width of the slit is very much greater than lambda. That is 4 times of the lambda. That is width of the slit is very much greater and wavelength is lesser. Now we are going to see what will happen. Case 4. Case 4. A is very much greater than lambda. This is a case. We will see what will happen here. Let's take the equation of the first minimum in single slit. A sin theta is equal to lambda. Sin theta is equal to lambda by A. Sin theta is equal to lambda divided by, how many times it is greater? Roughly I have taken 4 lambda. Cancel this lambda. This is equal to 1 by 4. That is sin theta is equal to 0.25. If you calculate theta, the angle value will be 14.4 degree. This angle is very much less. This angle is very less. If the angle is very much less means angular spread is very less. Angular spread is less means within this slit region itself, within the slit of the width, here, this is the width of the slit, no, within this region itself, the diffraction pattern is created, but it is not able to be observed. Or though it is created, you can't observe it. That's why I have written diffraction is not observed. The first minimum, central maxima, everything that falls within this region itself. So within the width of the slit itself, this one cannot be observed. Though it is created, you are not able to observe. That's why the fourth case is not suitable one to observe the diffraction pattern. Are you clear?